Hello everyone and welcome to Euclid Book 1 Proposition 8. So this is going to be Euclid's side-side-side proof. SSS is what a modern geometry textbook would call it. Basically, if two triangles, and here are two triangles here, have the three sides equal to the three sides, so all three sides of this are equal to the same lengths over here, then those two triangles are congruent, meaning in particular that the three angles will also be equal to the three angles. Okay, that's how it goes. Euclid does this proof again by just imagining setting one triangle down on top of the other, which, as I said before, would probably make modern mathematicians a little bit queasy. It just seems like there'd probably be an enhanced chance of you tricking yourself with that kind of argument, but that is the way Euclid goes. And he does use proposition 7 in this proof, as we'll see. So we'll go ahead and get started here. So Euclid says, if two triangles have the two sides equal to the two sides respectively, and have also the base equal to the base, they will also have the angles equal, which are contained by the equal straight lines. So, let ABC and DEF be two triangles having the two sides AB and AC equal to the two sides DE and DF respectively, namely AB to DE and AC to DF, and let them also have the base BC equal to the base EF. So in other words, draw yourself two triangles such that this side here equals this side here, this side here equals this side here, and this side here equals this side here. Okay, there we go. And then Euclid says, I say that the angle BAC is also equal to the angle EDF. So Euclid's claim is that this angle right here is equal to this angle right here, and that's what he's going to prove now. So here we go. And he says, for if the triangle ABC be applied to the triangle DEF, and the point B be placed on the point E, and the straight line BC on EF, the point C will also coincide with F because BC is equal to EF. So in other words, what he's saying is imagine taking this triangle here and just dropping it down on top of this triangle so that point B is sitting on top of point E, and so that line BC is lined up with line EF. And then he says if you do that, then because we already know that BC is the same length as EF, then it must be the case that C will also sit on top of F. Okay, and that should make a lot of sense to you. So after you have that done, then you've agreed that B is sitting on top of E and C is sitting on top of F. So in a sense, the only thing remaining to do here is show that A is sitting on top of D. So here we go. Euclid goes on. Then BC coinciding with EF, BC comma AC will also coincide with ED comma DF. So he says if this is sitting on top of this exactly, then it will also be true that this is sitting on top of this and that this is sitting on top of that. How does he get there? Well, here's what he says. For if the base BC coincides with the base EF, and the sides BA and AC do not coincide with ED and DF, but fall beside them as EG and GF, okay, let's pause there for a second. So Euclid is saying, basically, if this line does not sit on top of this line, and this line does not sit on top of this line, then they're going to meet somewhere else, which makes sense. They either have to meet at the same point, or they have to meet somewhere else. So let's just say, Euclid says, let's just say if we set this triangle down on top of this triangle, let's pretend that this line does line up with this line, but this line actually comes to some other point which we can call G, so I'll go ahead and put it in there, right there. And this line then, which of course starts at the same originating point, would have to be here. So he says, let's just suppose, I mean, if A does not sit on top of D, then A must sit somewhere else. Let's just call that point G. Why not? Okay, you can. So Euclid says, suppose that. And he continues. Then, given two straight lines constructed on a straight line from its extremities and meeting at a point, there will have been constructed on the same straight line from its extremities and on the same side of it two other straight lines meeting at another point and equal to the former two respectively, namely each to that which has the same extremity with it, but they cannot be so constructed according to proposition 7. In other words, if you remember proposition 7, if you have this line here and take some point here, there's some distance from here to here, and there's some distance from here to here. And remember, there is no other point up here anywhere that you can mark such that this length will be the same and this length will be the same. Okay, proposition told us that was impossible. But over here, we've said, well, if A does not meet on top of D, then it does not lay on top of D, then it must lay in some other point, call it G. But it must be the case that GE is equal to AB and that GF is equal to AC for another point. But by proposition 7, that is impossible. There is no other point. Only one point works. Only one point will have exactly those distances. And so it can't be the case that A lays on some other point called G. And so then it must be the case the A lays exactly on top of D. And so that's how he finishes. Therefore, it is not possible that if the base BC be applied to the base EF, the sides BA and AC should not coincide with ED and DF. They will therefore coincide. So Euclid says this is impossible. So it must in fact be the case that AB sits exactly on top of DE, and it must be the case that AC sits exactly on top of DF. Okay, this is not possible. They will therefore coincide, and so then Euclid finishes, since these two triangles are sitting exactly on top of each other, so that the angle BAC will also coincide with the angle EDF and will be equal to it if therefore etc. QED. So in other words, since these triangles are now sitting exactly on top of each other, it must be the case that this angle is exactly equal to this angle, and you're correct that it must be the case that all three angles are in fact equal to all three angles. And then that's the end. So Euclid says QED. That is the side-side-side proof for Euclid.